Okay, so here we've got a 3D problem. The diagram shows an office tower of total height 126 meters. It consists of a square-based pyramid on top of a cuboid. V is directly above the center of the base of the office tower. The length of the sloping ledge VC is 22.5 meters, and the angle that VC makes with the base is this angle here. Okay, so write down the length VA in meters. So if V is directly above the middle and the base is a square, then VA has to be just the same as VC. Okay, so that's just going to be 22.5 meters. Easy enough. Sketch triangle VCA showing clearly the length of VC and the side of the angle VCA. Alright, well, VCA, there's V, there's A, there's C. That's 22.5. That's also 22.5. And VCA is from V to C to A. So this angle here is 53.1 degrees. Right, next up. What's next? Show that the height of the pyramid is 18 meters, correct to 3 significant figures. Well, this triangle here goes right through the middle. That's VCA. Okay, so the height up here is the same as the height of this triangle. So splitting this isosceles triangle in half, we're going to have a right angle triangle here, and I know the angle, I know the hypotenuse, and I need to work out the side that's opposite the angle. So I'm going to use this, opposite and hypotenuse. If I'm working out the opposite, it's going to be sine of the angle times hypotenuse. So I can just do that here. Actually, I'll just do it over here. So sine of the angle, 53.1. Let's just check something. I think this calculator's in radians. I need to make sure I'm in degrees. There we go. Let's do that first. Alright, so sine 53.1, and then we need to multiply that answer by 22.5, our hypotenuse. Okay, so to 3 significant figures, that is actually 3 significant figures is going to be 18.0, because this is our 1, 2, 3 significant figures, and the fourth one means we have to round this up, and that 0 is significant. Yep, that's what we were supposed to show. Hang on, show that. I can't just write that as an answer, can I? I need to actually show what I did. Alright, I've got no marks whatsoever there. So sine of 53.1 degrees times 22.5. Right, calculate the length of AC in meters. So from A to C, well, what I would do here is just use my same right angled triangle that I used in the last part. I think I would use the same right angle triangle, and I would use trigonometry again, because you've been given the angle and the side. You could also use Pythagoras because you've now got 2 lengths, but I'm just going to do, this is now be the adjacent length. Okay, so I'm just going to use Ca. So the adjacent one is cos of the angle times the hypotenuse. So cos 53.1 degrees times 22.5. That's going to give me this distance from A to the middle here, and I need A to C, so I'm just going to times that by 2. So 2 times that number. So 2 cos 53.1 times 22.5. Enter. Okay, so that gives me the length 27.0. I'll carry on with the three significant figures, meters. Okay, show that the length of BC is 19.1 meters. So where are we? BC, this distance here. Alright, am I going to do this? There's several ways we can do this one, I think. I would just use, this is a right angle triangle in here. So let's stick with right angle trigonometry. I've just worked out AC. Is that number in here. So let's just draw a diagram, and it's a square base. So call this X, call this X. Just so you know what I'm drawing, this is B, this is A, this is C, and this is 27.0. So bit of Pythagoras here. Let's get out. I'm going to say that 2 lots of x squared add x squared, equals 27.0 squared. Alright, so what do I need to do next? So x squared equals 27.0 squared divided by 2, and x is going to be the square root of that answer. Let's just do it like that and put this all in my calculator. So I need, well, my answer from before, I've still got it. Why not keep it accurate? Use that one. So what I had before, squared, enter, divided by 2, enter, and then we want to square root the whole thing. So second square root, no, second answer, enter. So x is what it was supposed to be, 19.1 degrees, and I've shown how I've worked it out. I've got my sketch there. I think that'll do that nicely. Right, I've done that one. I'm on to part E. Calculate the volume of the tower. So I need the volume of the cuboid plus the volume of the pyramid. Okay, so volume of the cuboid. Hang on, I need to work out a few little bits on here. Let's just write in some of the answers I've got already. I'm going to change pen because it's getting all a bit the same. So the whole thing is 126. I worked out that the height of the pyramid was 18. So that's 18 there, which means 1, 2, 6. Oh, not divided by. Take away 18. Okay, 108. Alright, so that's 108 from there to there. I also worked out, what did I work out, AB or BC? I can't remember. BC and AB are the same, and I worked out, or in fact, even if I hadn't, it was given to me, that's 19.1. Okay, so I've got, this is also going to be 19.1, and this is 19.1. Okay, that should be everything I need now. So first of all, the cuboid at the bottom, I need height times width times length, so 19.1 times 19.1 times 108. So that's this one, 19.1 times 19.1 times 108. Okay, that's the cuboid. I need to add the height of the pyramid, and the pyramid is given by 1/3 of the base area, which is again 19.1 times, so a third times 9.1 times 19.1 times the height, which was 18. So I need to add these two bits up together, and that is going to give me the total volume. I'm going to put that all on my calculator. 19.1 times 19.1 times 108, add 1/3 times 19.1 times 19.1 times 18. Okay, so that's going to give me the volume. Let's write out the whole thing to start with. So I've got 4158.34. I should then give that to three significant figures, which would be 41600, and that's in meters cubed. Okay, because all my measurements are in meters. Okay, right. Finally, we need the weight of the tower. Given that 90% of that volume is air, okay, and 1 cubic meter of air weighs 1.2 kilograms. So all I need to do is, let's just come down here. Okay, so here's part F. Get that up here. I need to do my volume times 0.9 to get 90% of my volume, and then I need to times that by 1.2 to get the weight in kilograms. Okay, so I'm just going to keep my answer there, keep it more accurate, times 0.9 and then times 1.2. Okay, as I said, calculate. Yep, that looks fine. So we get 44915.4072. Let's give it to three significant figures. 44900 kilograms.